Assalamualaikum warahmatullahi wabarakatuh. Lesson for today we will consider the second chapter in organic, which is hydrocarbon. So this is the first homolog series we learn from the several homolog series. Okay. So for your information, our hydrocarbon consists two part. First part, alkenes. Second part is alkenes. So the two class of compound covers in 3 hours. So we try cover in alkane only 1 hours. So in alkenes in lesson 9, we are focused into the definition, the classifications of the hydrocarbon according to the properties of aliphatic or aromatic, saturated and unsaturated hydrocarbon, draw, and also the nomenclature of the hydrocarbon according to the IUPAC nomenclature. And we need to discuss the physical properties of the alkenes based on to the concept boiling point, solubility, and next part, the chemical reactions of alkane involved in the combustion. We have two criteria. The reactions of alkane involved in halogenation reactions. So focus on the type of reaction. We need to explain the mono-substitution alkane containing equivalent and non-equivalent types of the hydrogen. Finalize, we need to illustrate the mechanisms involved in alkene. So, who is our hydrocarbon? Our hydrocarbon here only consists of carbon and hydrogen only. So means the terms of hydro, the compound contain the element basically hydrogen, and carbon consists of the element for carbon atom. So this hydrocarbon can be classified into the first, saturated or unsaturated hydrocarbon. Second, aliphatic or aromatic hydrocarbon. Saturated hydrocarbon consists of what? Single bond. So means according to the saturated, you must be have carbon single bond. So and this we can classify as a homolog series of alkenes or cycloalkenes. And then the unsaturated, we can classify it must be consist of the multiple bond, either carbon-carbon double bond, cycloalkenes, carbon triple bond, and also the aromatic, the hydrocarbon. So, according to the aliphatic compounds of the hydrocarbon, means it must be have open chain, not closed ring. Means aliphatic must be consist connected carbon toward to the second carbon and finalized carbon. So they must be straight chains in octet with the several atom. For example, the hydrogen atom. Okay, so if the alkane, it consists of the aliphatic, alkene, cycloalkene, alkene, and so on. If aromatic hydrocarbon, it must be have at least one benzene, means one aromatic ring inside the structure. So this is the classifications of the hydrocarbon. Saturated must be consist alkane and cycloalkane containing our single bond. Unsaturated alkenes, cycloalkenes, carbon-carbon double bond, carbon-carbon triple bond, arene containing aromatic ring, and we can classify this is the aromatic of the hydrocarbon, and this is the aliphatic. So aliphatic, mostly we are can consider to the open chain of the structure. Okay, so this is the classification for each compound. So the first compound, this is the open chain. So this is classified as a saturated because all of them are consist on the covalently in single bond, and this is the open chain structure, and we can classify this is the aliphatic. So this is hydrocarbon directly attached to the ones of the aromatic ring. So this is also we can call unsaturated because consists of multiple bond in the ring. So we can classify this is aromatic hydrocarbon. Carbon-carbon triple bond unsaturated. This is the open chain aliphatic. So all of them are single bond saturated, and this is the aliphatic also. This is unsaturated, consists carbon multiple bond, but this is the aromatic hydrocarbon, consists of the aromatic ring. Multiple bond here, unsaturated, and this is also aliphatic hydrocarbon. Okay, now, how about the terms of alkane? If alkanes, it must be saturated hydrocarbon. Why? It only consists single bond between them. So remember, alkane no functional group. So the type of the hybridization according to the mainly covalently bond carbon have a 4 bonding pair. So the type of hybrid must be sp3, the shape must be tetrahedral, and the angle is 109.5. Okay. So this is we can classify as an open chain because carbon 1 cannot connected with the final carbon. So this is the in form of open chain. But cycloalkane must be connected carbon 1 and finalize carbon here. So this is the cycloalkane. Okay, so we learn about the nomenclature of the linear of the haloalkane. Generally, capital letter is not allowed naming in organic compound. Remember all of them by using the small letter. So you must be use the rule during the name your structure of the alkane. Rule number 1. First thing, you must be identify your longest continuous chain, and we can classify them as your parent. So this parent can be classified must be in form of alkane homolog series, and it does not consist of no functional group. So, if their homolog series consists of what? Your writing nomenclature at the end of the name must be A and E, and if we have the addition of the carbon atom, so if 1 carbon mat, 3 carbon prop, 7 carbon heptane, and also finalized 10 is taken. So your syllabus nomenclature basically parent change only 1 until 10 of the carbon atom. So, if this example, okay. First rules, you must be identify your longest chain. So your longest chain, you must be remember, okay. Your pen must be, cannot be up down. So pen kamu tidak terangkat. So means your first carbon here must be closer to the position first substituent group. So this is we can classify substituent group. So your first carbon must be closer to the position of substituent group, and your parent change must be continuously carbon, and we have the maximum numbers of carbon atom. So finally, you can find out 6 longest carbon. So this is why your parent chain become hexane. And next, we find out the total number of the parent chain consists 1 until 7. So, your numbering number 1 must be closer to the position of the substituent group. Similar for part here. So, our longest chain here is 8. So, your numbering carbon 1 must be closer to the position of the substituent group. So, this is the 8 carbon atom. Your longest chain become octane. Okay, rule number. After you already identify your longest your parent change that contain longest carbon, you must be find out the substituent group that really attached to your parent carbon. So we have the several common substituent group, and you must be remember the name. So if we have the several carbon, we become the group of substituent. The naming of the them must be labeled as the THYL at the end of the substituent writing name. So if the 1 carbon atom, this is a methyl, 2 carbon atom, ethyl, 3 carbon atom, propyl, and we have the commonly name which is 3 carbon atom. So this is we can call isopropyl. So you must be remember for this we have a 3 carbon atom, and we have the CH3 attached to your center of the carbon. So this bonding pair directly attached to your parent. Pi label is your longest carbon here. So this substituent we can classify as a isopropyl. And if you have here, okay, we have a parent chain here, and the substituent group we have a 4. So if 4, the name become butyl. Next part. Okay. The substituent group also we have a 1, 2, 3, 4 carbon atom. So basically your common name here is the isobutyl. Why the common name we can call isobutyl? Because we have CH3 group attached to the same carbon atom, and this carbon directly attached to your parent chain, or the IUPAC name as your substituent become 2-methyl propyl, because this is your first substituent attached to your parent and this is your second substituent. So if you have here 4 carbon atom also, but your parent chain directly attached to the second carbon in substituent. So substituent kita ada 1, 2, 3, 4 carbon atom. So this common name we can call circ-butyl or 1-methyl propyl. And we have the here 1, 2, 3, 4, 4 carbon atom, and the shape become T. So this is why we can label as a name common as a third butyl or 2-methyl propyl. So the center of the carbon that is attached to your parent chain. So this is your substituent 5 carbon atom become a pentyl. If we have the CH3 group at the same carbon atom, we can call iso. Why pentyl? Because our substituent consists of 5 carbon atom. So for your information, all the common name we can accept the nomenclature as a IUPAC together. Okay, similar for here. The substituent group consists 1, 2, 3, 4, 5 carbon atom. So this is a become pentyl 5 carbon, and neo here ataupun nama IUPAC-nya as is lah 2,2-dimethyl propyl. And we have the substituent according to the cyclo shape. So we can accept 1, 2, 3 carbon atoms. So the name becomes cyclopropyl, and this carbon atom directly attached to your parent. Similar for the second part, cyclobutyl, but we have the aromatic ring here. If aromatic directly attached to your parent, parent kita adalah longest carbon. So this aromatic ring we can call a substituent as a name phenyl. And if we have the new CH2 attached to your aromatic ring, and the next carbon baru di attached pada parent. So the all group here we can classify as a benzyl substituents. So remember, you must be remember all the nomenclature of the substituent group, especially all the common name. Okay, if we have the several element or group of atom here, the nomenclature as here become fluoro, chloro, bromo, iodo, and finalize sometime OH becomes substituent. So the name here become hydroxy without L. NH2 becomes substituent amino, and O2 is a nitro. Okay, so after you already identify 2 rules, first rule is the longest carbon, second rule identify the substituent group, and the third rule adalah you must be label your numbering of the carbon atom. Your first carbon atom must be starting the closer to the position of the substituent group. So means that rule number 3 must be number of first carbon closer to position substituent group. Okay, so this is the numbering for the carbon atom. So our substituent group is methyl. So your first carbon must be numbering at the end of the chain closer to the position methyl group, means so this is why the first carbon at here, and the longest carbon we have a 6 carbon atom. So we can label for numbering of the substituent attached carbon number 2. Similar for here, longest carbon consists 7, and your carbon number 1 must be the closer position our first substituent group. So this is why number 1 at the downside here. So after then that, the rule number 4, you must be allocate the numbering of the substituent group, and remember your writing of the substituent must be at the front of your parent chain, and then both sentence atau both name substituent and parent must be closer, and you must label your substituent, so the numbering to the sentence you must be use the hyphen. So this is why to means a location of substituent, dash who is our substituent, methyl, and who is our parent, total carbon is hexane. So the next rule, if we have two or more substituent group, remember your substituent group must be labeled as an alphabet numbering. So if we have the similar or identical substituent, means CH3 group 2 times, you must be labeled di, tri, and so on. Third, and so on. So ignore iso and neo. Iso and neo is the specific nomenclature for the common nomenclature for here. Okay, and the rule number 6 is, if when we have a two substituent carbon atom, use a number twicely. Means we have the two substituent directly attached to the same carbon atom. So during you write down the name, you must be labeled twicely the numbering of who is our substituent. This is why 3-ethyl, 3-methyl, and finalize your longest carbon hexane. So the next rule, if we have the similar substituent group attached to the different carbon atom, so you just labeling how many times of substituent and label their location of substituent. Remember, if we have a two substituent here, the numbering you must use a comma symbol, number to the sentence hyphen symbol. And next rule, when we calculate the longest carbon from left to the right, or from right to the left, the number of carbon atoms similar, you must be choose the calculation here, the highest numbers of substituent group. So therefore, the situation for here, we writing from right to the left here, 1 to 7, or down. This is also 1 to 7. But when we calculate the total of the substituent, the position for here, we have the highest number of the substituent group. So this answer is incorrect. Either the longest carbon is 7, but the total substituent here consists 1, 2, and 3 only. So this is cannot be acceptable is our nomenclature of the compound. Next rule, when you want to find out your first carbon location, numbering your first carbon must be at the end of the chain. But from left or right, we can have the similar, identical, the longest carbon here. So what happened? You must be arrange them, have the lowest of first point difference. Means if this situation, our substituent allocate carbon number 5, 3, and 2. So therefore, I arrange the numbering substituent 3, 2, 3, 5. But the second situation, we can also the numbering as 1, 2, 3, 4, 5, 6. So therefore, our substituent attach carbon number 2, carbon number 4, and also carbon number 5, and we rearrange for this situation, numbering 2, 4, 5. So if the longest carbon numbering position carbon are same, but you must be referred to the first point different. Means this is our first point, this is your second point substituent, and finalize this is your third substituent group. So you must be identify which numbering come first. So position substituent carbon number 1 cannot be find out differences. But position substituent number 2, the first we find out location number 3. So the numbering of the substituent, we can accept your red color for here. We can call first point different. But if the compound consists of the cycloalkane, the rules are same. But the naming of the parent change, you must be labeled cycloalkene. So, this is the nomenclature. If the 3 carbon cyclopropane, 5 carbon cyclopentane according to their own number of carbon atom. So, next rule, after we identify your longest carbon, your numbering carbon, your first carbon must be directly attached to your substituent. But if we have only one substituent attached to the parent chain cyclo, no label location substituent. Means if you rating 1 chloro cyclopropane, so this answer is incorrect because numbering here not necessary. So according to your cyclic compound, substituent group is always at the end of the chain, which is the lowest position of carbon. So we just accept the numbering, naming for here chlorocyclopropane. Next, if we have two substituent group or more substituent group, so what happened? You must be label your substituent according to the alphabetical order and have the lowest possible of the number of carbon atom. So the first substituent here, we have methyl. Second substituent, ethyl. So, who is your carbon number 1? Where location? You must be follow alphabet. E first. This is M. So, this is why E, the first alphabet come first. So, this is must be carbon number 1. And this is your carbon number 2. So, your longest carbon containing 6 carbon atoms. So this is why your nomenclature for parent is the cyclohexane. And the name must be arranged follow alphabet. E come first. So the name must be 1 ethyl, 2 methyl cyclohexane. Okay, similar for here. Two identical, so lowest position of the substituent, which is the lowest carbon atom. So this is number 1 and number 3. So this is identical, 1, 3, dichlorocyclopentane. Next rule. If you have a 3 or more substituent, 3 or more substituent group, you must be allocate your numbering of the carbon atom of your substituent must be lowest possible number. So this is why we can accept numbering for here is number 1, number 2, number 4. Second possibility, or number 1, number 2, 3, 4. So, the red color, the position substituent allocate number 1, comma, 3, 4. The blue color numbering of substituent 1, 2, 4. Who come first? Follow first point difference. So, this is should be accepted. Okay, similar for here. So, this is 1, 1, 3. Not the red color. This is number 1. This is number 3. So, or 1, 3, 3. So, your first point difference, second point, 1 come first. So, this is acceptable. This is cannot be accept as your first point difference in labeling as your substituent group. Okay. Okay. If we have the cycloalkane, directly attached to the longest carbon, and this longest carbon consists greater number of carbon atom, your cycloalkene will become substituent group. So this is become the name cyclobutylpentane. But what happen if we have the more number of the cycloalkane? This is also become substituent whether the longest carbon is less of them. So the name here dicyclohexane propane. Okay, now we try for the example page 66 in our reference books. Okay, so name for the compound given. Remember the rule. First rule, you must be identified. Okay, I label the step for here. Step here, you must be labeled parent. Your parent chain must be have higher number of carbon atom. And remember, step number 2, you must be identify who is your substituent group. And then step number 3, basically allocate carbon number 1 at lowest position substituent group. Okay, this is we focus first. So when we are calculate, we can find 1, 2, 3, 4, 5, 6 carbon atom from left to the right. But when we are test again, maybe we can find 1, 2, 3, 4, 5, 6, 7. So the longest carbon yang berwarna merah adalah 7 carbon, but yang the blue color is a 6 carbon atom. So yang menang sekarang adalah 7 carbon atom. So this is your longest carbon atom is the red color for here. Okay, now our task here, label the number specific of the carbon atom. Okay, so when we identify after your longest substituent group, we can find 1, 2, 3 substituent group. So this substituent we are labeled as a methyl group, because this is consists a CH3 group, and the numbering of the carbon number 1 must be at the end of the chain for the first substituent group come out. So di mana this carbon must be allocate carbon number 1, because your first substituent closer to the chain at the end of the chain. So this is carbon number 1, 2, 3, 4, 5, 6, 7. So we can write down the name for the structure. The longest carbon consists 7 carbon atom, and we label the parent chain is the heptane. And we have the substituent group, they are identical. So we label the substituent and in front here. Methyl, how many times? 1, 2, 3 CH3. So it must be write down the total up your substituent. Trimethyl, allocate your substituent position. So they are identical. 2, 3, 5. So if the different number, you must use the comma. From number toward the center, you must use the hyphen. So this is our correct name for the question number 1. Okay. Focus to the question number 2. Cycloalkene. If this cycloalkene, we have the 2 substituent, you must be label. Your first carbon must be follow alphabet. So we can find out. CH2, CH3 we can label as a ethyl. CH3 we label as a methyl. So where the location carbon number 1 follow alphabetical order. E come first, so this is why this is must be number 1, number 2, 3, 4, 5, 6. So your longest carbon consists 6 in form of cyclo. So the name for the structure number 2, your parent is cyclo 6 carbon atom, hexane. Substituent group follow alphabet. So means ethyl first, baru methyl. So kita akan tulis dekat depan. Ethyl, where's the location? Carbon number 1. 1 dash ethyl dash location methyl, carbon number 3 dash for the next substituent methyl. So the name 1-ethyl 3-methyl cyclohexane. Okay, so for the rest question, you must be try to find out and try to complete all the nomenclature. So from this question means the exercise example page 66 until 68 as your task.